The other day I made a really interesting discovery with my students using wood glue under a vacuum. Check it out.
Yeah, this is that air pocket.
I see some bubbles.
Trying to suck the air out. Whoa!
That is cool.
So the next obvious question is, what's causing this? I totally didn't expect it to happen that way and have so many bubbles forming, so what was the cause? Before we answer that, let's take a look at what happens under a vacuum and talk about air pressure. So I have an empty plastic bottle here, and what happens to this empty plastic bottle if we put it under a vacuum? What do you predict is going to happen? Okay, so if you predicted that it would get crushed or it would expand or something like that, it didn't. Why is that? It's still under a vacuum. It's still tightly sealed. I can't even lift the lid off of it. So why didn't it get crushed? Under normal atmospheric pressure, there's 14.8 pounds per square inch pressing on the sides of this bottle. But there's also 14.8 pounds per square inch pushing from the inside out. The bottle's not empty, it does contain air. So when we put it under the vacuum and had it into the vacuum chamber, turned on the vacuum and reduced the pressure, all it did was remove all of the air from around the bottle and from the inside of the bottle. So therefore we didn't see any effect. So if we cap it off and trap the 14.8 pounds per square inch of pressure inside of the bottle, let's see what happens then. Just like with the bottle that we just saw, we can see the same effect with some balloons. Okay, so as we've seen, if you have air under the vacuum, that 14.8 pounds per square inch wants to expand and go towards the lower pressure that's created outside of it in the vacuum chamber. So when we looked at the wood glue, my first initial reaction was this.
It apparently has a lot of air suspended in the glue, and that's what's coming out when that happens.
See, I was thinking about it in terms of the air expanding, and that must be suspended air inside of this glue. But an interesting thing happened to me. In the middle of the night, I woke up thinking maybe it was something else that was the cause of this. Maybe it was the glue was boiling. You see, water will boil at a much lower temperature if you lower the pressure. That's why when you go to higher elevation, water boils at a lower temperature. So to test whether or not it was actually the glue boiling versus air bubbles inside expanding, I thought what I'd do is put both of them in the chamber at the same time, put some glue in the chamber and some water. I put food coloring in the water so it was a little bit easier to see and show up on camera. So let's try it out. We'll set it up and have glue versus water and see which one boils faster or if they boil at the same time. Okay, so what do we learn from this? We learned that you got to be careful about jumping to conclusions. The results here seem to show that what's happening is it's actually the boiling of the water that's in the glue that's causing it to bubble up so much. When I checked out the MSDS sheet for this Titebond wood glue, what I found is the boiling point was at 210 degrees. So if you noticed on the video, if you look back, you'll see that it starts to boil a little bit before you can see the water boiling, which is at 212 degrees. So we weren't changing the temperature of these. They're actually just room temperature, which is about 65 degrees in here. But what we did do is we lowered the pressure enough that the water escaped and became a vapor much more easily than it would at regular air pressure. So when you lower that pressure, it's much easier for those water molecules to escape and to become a vapor. Thanks for watching, I appreciate it. Click thumbs up if you enjoyed this video and if you learned something from it. I'm going to be doing more vacuum chamber experiments, so look for those, and there's going to be a lot more content coming out on the Brainstem channel. Until next time, keep asking questions and seeking answers.